So I was just told they still need a few minutes to get the webcast going, but we'll go ahead and start with the session because otherwise it's just really getting too late. Apologies for that. We will try to go a little bit past noon. Those of you who have to leave, please go ahead and do so. Apologies for that. So as Sybil said, good morning to everybody here and those of you in the webcast that will join us later, I hope. Sorry for the technical difficulties. Those are things beyond our control. As Sybil said, the Forest Carbon Management Project of the Pacific Institute for Climate Solutions is a collaborative effort of a number of universities and various agencies in provincial and federal governments, including our team at the Pacific Forestry Centre of the Canadian Forest Service in Victoria. What I want to do this morning is speak to you about the role of forests and forest products in decarbonization. I will introduce just briefly some of the concepts of what we have been working on, and then we'll hand it over to the speakers who will present you with the details. As we all know, climate change is real. 2016 was the hottest year on record, and it was that again. It was the third year in a row that we recorded the warmest year on record. And in fact, in the world, we saw very large increases in temperatures, as had been predicted many decades ago. These temperature increases were highest in the north and in the continental regions. This is the temperature anomaly for February 2017, so it's a one-month average, not a single day. And as you can see, we have temperatures that are well above 4 degrees centigrade higher than the long-term average, the climate normal for 1951 to 1980. And we have many other maps like that of temperature increases in recent years. And as you will see, these are consistent with what global models predict. These are two results of the predicted future temperatures under two emission scenarios conducted by the Intergovernmental Panel on Climate Change. The left is the world that we strive to achieve with the Paris Agreement, a world in which temperature increases on average will be globally less than 2 degrees centigrade. The right is the world that it could be if we continue on the trajectory that we are on right now with the burning of fossil fuels and the increases of greenhouse gases in the global atmosphere. The choice is that of humanity. Humanity will also suffer the consequences of the choices that we make. Now, there's some good news. And that is expressing itself in the trajectory of CO2 emissions that have occurred over the last years. And the good news is that after a period of exponential growth, we have seen in recent years a leveling off in the greenhouse gas emissions, and that is very largely due to the contributions that China has made in recent years, succeeding in leveling off their greenhouse gas emissions. And there's certainly indications that they may have already peaked. The other good news is that of the emissions that we add to the atmosphere every year, only about half, less than half in fact, is remaining there. As you can see here on the left, the two major sources of greenhouse gas emissions to the atmosphere are fossil fuel burning and deforestation. That is the land use change of forest to non-forest land uses predominantly in tropical and subtropical regions around the world. Of these emissions, 44% remain in the atmosphere, and the others are taken up by forests globally and by oceans. Now, ocean uptake of carbon dioxide leads to ocean acidification, so this is not necessarily a desirable thing. And the other thing that we don't know about very well is how long the global forest ecosystems will continue to operate as carbon sinks into the future, and whether that sink strength might be saturating and leveling off or even declining in the future. So there's a lot of interest in how we can deal with carbon dioxide concentrations in the Earth's atmosphere. Humanity got together in Paris in 2018, and this was a real game changer in many ways because 193 nations, including developing countries such as China and India, agreed to a target of keeping temperature increases well below the 2 degrees centigrade. But what is also important for our community is that almost 150 countries have recognized the importance of the land sector, that is, the contribution of forest management and agricultural activities in achieving greenhouse gas emission reduction targets. And the reason this is so important is expressed in this diagram, and that is that in order to achieve the cooler of the two worlds that you saw earlier, we need to be on the trajectory of greenhouse gas emissions, the lowest of the trajectories of greenhouse gas emissions or greenhouse gas concentrations in the Earth's atmosphere that is shown on the left. If the CO2 concentrations follow the blue trajectory, the upper one on the right, then we get the hottest of the Earths that we saw in the earlier diagram. So that means two things. One is emissions from fossil fuel burning have to peak in the next decade and then decline. But more importantly, the emissions have to become net negative in the latter part of this century. And that is a term you will hear a lot more of in the coming decades, because what it means is that the human activities need to be able to, of removing more CO2 from the atmosphere than we're adding to it. If we fail to achieve that, then we cannot reach the goal of 2 degrees centigrade. So there are two ways of removing carbon dioxide from the atmosphere. One is, of course, the engineering approach of building facilities that extract carbon dioxide from the atmosphere, liquefy it, then pump it under the earth or underground, or turn it into other valuable products. And in fact, a prize has been offered in 2015 to those who can develop new groundbreaking transformational approaches to converting CO2 emissions into valuable products. And those of us in the forestry community are looking at this and are going, well, wait, isn't this what we have been doing all along? Namely, turning carbon dioxide from the atmosphere through photosynthesis, taking the carbon, storing it in biomass, releasing the oxygen back into the atmosphere, and eventually harvesting that wood and turning it into valuable products. Oops. So what I will speak about briefly are some of the analyses that we have done by our team, and team members will then go into more details about how forest sector climate change mitigation options may help contribute to affecting the greenhouse gas balance in British Columbia and Canada more broadly, and in particular how and whether we can contribute to the legislated greenhouse gas emission reduction target of 80% below 2007 levels by 2050. These analyses are conducted at the scale of forest management units across British Columbia. There's 74 of these that we show on this map here. And we apply existing models and tools to calculate, based on inventory and growth and yield information and information about forest disturbances and human activities, the greenhouse gas balance of these forests. We take a systems perspective, and what that means is that we do not focus only on how much carbon is stored in forest ecosystems, but following the guidance of the Intergovernmental Panel on Climate Change, we look at the system as an entity. We need to understand carbon emissions and carbon storage from forest ecosystems. We need to account for, estimate, report, and account for carbon stocks and emissions associated with harvested wood products and their use, and that would include also bioenergy. And we need to estimate and report the changes in emissions from substitution benefits. And what I mean by that is that if we use a wood-based product instead of an emissions-intensive material like steel, concrete, plastics, aluminum, or other such materials, we can achieve a reduction in emissions, because not only is the wood storing the carbon, that is the second bullet here, but we also have fewer emissions from wood use than we would have had we used concrete, steel, or other materials. And when we do mitigation analyses, we also need to always compare a business as usual base case against the mitigation activities so that we can capture the additionality or the impact of the mitigation action that we have implemented. We do this using the same framework, or much of the same framework, that we're also using for greenhouse gas reporting in British Columbia and Canada. We have a well-established carbon budget model that estimates carbon stocks and greenhouse gas emissions and removals in forests. It counts for carbon in biomass, in dead wood, in standing dead trees, in litter, in soil. So it does a full estimation of the carbon cycle in ecosystems. We keep track of how much carbon is harvested and transferred to wood products and biofuels, and we have a tool that allows us to estimate the fate of that carbon that was harvested in British Columbia or Canada. how much of that wood remains stored and how much of it is emitted as these products are used or burned, as wood decays, and ultimately is disposed of in landfills. And we have tools to allow us to estimate the substitution benefits, the impacts of using wood instead of fossil fuels and other products. And as you can appreciate, that depends on many factors. If you use wood to substitute for electricity in British Columbia, you have a very small substitution benefit because most of our electricity comes from hydroelectricity. On the other hand, if you use wood to generate electricity or heat in a remote off-grid community where the electricity would alternatively be produced by a diesel generator where the diesel is trucked in over long distances or even flown in with very high embodied emissions, obviously, if you use wood there, the reduction in emissions would be much greater than in the hydroelectric situation. And so the same applies for products. What kind of wood products are used and what products they substitute also makes a big difference, can make a big difference. And so these tools try to estimate these substitution benefits. The focus of a lot of what we'll be talking about today is a particular study that is one of many, but one that was done specifically for this project for British Columbia. Zach will be speaking to this, and Carolyn in a few minutes after me. But I just want to give you the highlight. What this study does is it looked at a number of different climate change mitigation options in the forest sector, and we'll go through the details with Carolyn's presentation. It also looked at alternatives of how we use the wood, as that matters greatly as well. And we then concluded that in British Columbia, 35% of the greenhouse gas emission reduction target for 2050 can be contributed by the forest sector at a cost of less than $100 a ton of carbon dioxide equivalent, and that there will be additional socioeconomic and ecological benefits. So $100 a ton may sound like a lot of money to you, but if you look at the cost of climate change mitigation in other sectors, in particular that of carbon capture and storage facilities, they're currently operating in the range of $200 to $300 a ton. And of course, there will be technological improvement. Those costs will go down, but similarly, we will be able to identify also more cost-effective ways of dealing with mitigation options. So the point are twofold. One is the forest sector contribution is meaningful in terms of its magnitude, and secondly, it's cost-effective. You'll see a few graphs later like this where we try to quantify the contribution to the mitigation into the components that contributed to this greenhouse gas emission reduction. So you'll see bar charts like this where the scenario that was explored is shown. So in this case, this first example, it's the use of more long-lived wood products. So no change in harvest rates. It's just how we use the wood differs a little bit. We made a very conservative assumption saying that, well, what if 4% of the wood that would go to pulp and paper instead is used for more long-lived products like panels that you can also use in buildings, so you can achieve some substitution benefits through product displacement. And so what the bar shows is that the combined impact of this change in activity would contribute by 2050 a mere 3% of the greenhouse gas emission reduction target in British Columbia, but it's a very, very conservative and small change that we made with just 4% of the pulp and paper being used for panels. And so you see here there are two colors. The red is the benefit in the harvested wood products, and so reduced emissions because you put the wood into more long-lived products. And the darker blue is the benefit of product displacement of using panels instead of other materials. Another scenario that we will hear more about in detail is a harvest-less scenario. Again, a very conservative assumption. We simply said, relative to the baseline of projected harvest to 2050, we harvest 2% less. And now what you see is we have reduced emissions from the forest ecosystem, so we get a positive mitigation benefit there. We have reduced emissions from harvested wood products because some of the material that we harvest is short-lived. But we also have a small negative contribution. That's the dark blue line, the product displacement that has a negative. And so the balance of these three is the black line. It gets more complicated and more interesting when we start looking at a scenario where we use the residues that are currently left behind, and some of them are burned in slash piles. And instead of leaving them in the forest, we take them out of the forest. So now we have less residues that are decomposing there. So we have the contribution of reduced greenhouse gas emissions from the forest because we have fewer emissions there. But of course, we took that material out and we're now using it for bioenergy in this example. What that gives us is the light blue. It's the product displacement benefit of having used the wood instead of fossil fuels to produce the energy. But because we burn those residues, we have negative emission benefits. That's the red blocks at the bottom. That gives us the increased emissions from woody biomass. And so you see how the systems approach works by looking at the contribution of each component. And you see in this case, we can achieve 11% of the greenhouse gas emission reduction target. And then the last one that I just want to introduce briefly, and Carolyn and Zach will speak to more of these options. And the last example, we have a portfolio of doing what appear to be the best option in each of these 74 management units. We pick all those that have positive contributions and only use those and use in each management unit those that are the best. And sometimes we combine them, so more longer lived products with some of the other strategies. And now we get to 35% of the emission reductions, partly by reducing emissions from forests, increasing the substitution benefits from energy displacement. There are also positive and negative product displacement benefits. That's why there is no bar. They offset each other. So in some of the strategies lead to greater product displacement, others to less. And so that contribution is canceled out. And then we have, of course, increased emissions from the harvested wood product sector because of, in this case, largely the increased burning for bioenergy. So it's a combination of increased long-lived wood products, more use for bioenergy, et cetera. And when you combine all that, you see that the portfolio that we have identified thus far, and we have many more options to look at, can deliver 35% of BC's emission reduction target by 2050 if these mitigation activities are implemented soon and if they are sustained into the future. I like putting this picture in because when we talk about 1 million tons or 1 million cubic meters, it's very hard to visualize. This is an example of this is a salvage logging operation in Sweden after a big wind throw event, but it shows 1 million cubic meters of wood, or about 1 million tons of CO2 equivalent. And in British Columbia, we harvest every year about 70 times this amount. And what we do with this wood is hugely important. Just to put it in perspective, the amount of carbon dioxide that is in this wood that is taken out of forests and when the forests are regrowing, that carbon is removed from the atmosphere, that amount of carbon is about 65 megatons of carbon dioxide, which is roughly the same amount of the emissions from all other sectors in British Columbia. So what we do with this wood, how we use it, how we help it to decarbonize the fossil aspects of our economies is hugely important, and as is, of course, ensuring that forests regrow where they have been planted and harvested. So one of the things that we have learned in this work is that when we think about wood use, we need to think about two key indicators. One is how long will the carbon be retained in the products that we produce, and the other one is how will the product that we have produced help us to displace emissions from other products and fossil fuels. And so if we look at bioenergy, we're sort of at the lower left-hand corner. We have a range of possible displacement factors, some positive, some negative, and we have very short-lived carbon. If we go to paper, packaging, and panels, we sort of shift to the right with greater carbon retention time and higher displacement factors. Where we really can make a difference, though, is by looking at using the wood in long-lived structural building products, because as we move from the lower left to the upper right, we achieve higher mitigation benefits. Now, some of these activities are linked together because as we produce more structural building materials, we also produce more cuttings and bark, et cetera, that we can use for other purposes, such as bioenergy, to help further increase our mitigation benefits. So they should not be seen in isolation. And of course, we know this in British Columbia. We changed the building code in 2008 to allow 8-story buildings. The Wood Innovation Design Center in Prince George is an example of that. It was for the longest time the tallest building in North America. We now have the tallest contemporary wooden building in the world with the 18-story building at Brock's Commons on UBC campus. The other question, of course, is then what do we do with what are other ways to reduce emissions? And one of the topics that we have been looking at quite a bit is possible alternate uses for wood that is currently left behind in forests and often burned for the purpose of reducing fire risks. These are practices that cause significant greenhouse gas emissions without capturing the energy that is contained in these materials, and obviously an area in which climate change mitigations may be possible. I won't go into details. Robbie will speak to more of this, but one of the other things, of course, that we need to be mindful of is that there are both positive and negative impacts of climate change on growth, mortality, and disturbances. So understanding where, when, and how climate change impacts will occur in British Columbia is necessary to help us design the appropriate and effective climate change mitigation and adaptation strategies. And so this PICS project is working towards this goal as well. So in summary, and to set the stage for the other upcoming presentations, there are three big research themes in the project: the design and evaluation of regionally differentiated climate change mitigation options, as well as the assessment of their outcomes in terms of economic and other indicators. The assessment of the impacts of climate change and using that information to help us design adaptation and mitigation strategies to reduce these adverse impacts where they occur. And then the work that is led out of UBC with design and evaluation of policies, institutional and financing options for forest carbon mitigation options. And we will hear from George and Guillaume on that topic. So in conclusion, the 2-degree goal of the Paris Agreement cannot be reached without significant reductions in burnings of fossil fuels. I think that goes without saying. But also the important potential contribution of the global forest sector and the forest sector in British Columbia to contributing to net negative emissions. The PICS research team therefore focuses on how the forest sector can mitigate climate change, how forests will respond to the changing environment, and what policies can help achieve mitigation objectives cost effectively and with the support of the public. What our results have shown so far is that BC's forest sector can make significant contributions to climate change mitigation, and that this contribution increases if the mitigation actions start soon and are sustained into the future. And with that, I thank you. And I think we're going to go through all three presentations first and then have questions. So thank you very much, and I'll hand it over to Carolyn for the next presentation, and I'll start bringing that up.
I think I can use the...
And we are live, by the way, to both the PICS YouTube site and also to the SFU's webcasting channel.
Okay, so maybe just welcome Katie.
Yes. Do we need that email up again for questions?
No.
Okay. Perfect. Well, thank you very much. And welcome everyone to the webcast of the PICS Forest Carbon Management Project. Delighted to be here today, and today we're going to be telling you about some of the analysis we've been doing over the past few years. And for this presentation, it's going to be a tag team with myself and Zach Chu, and we're going to talk about the mitigation options for BC's forest sector. And I will start by introducing the biophysical mitigation potential, the results of our modeling analysis. And then I'll pass it over to Zach, who will handle the economic and socio-economic impacts of implementing those options. I'm a soft speaker, sorry. Yes, I'll hold it a little bit higher. So to start, I just want to emphasize that we are using a systems approach for estimating the mitigation of the forest sector. And this isn't always done. Sometimes it's done in certain parts. They consider it mitigation in the forest or mitigation for harvested wood products. But really, these sectors interact. So from the forest ecosystem, we can have harvest, which creates products to meet society's demands, such as bioenergy and wood products. And these then therefore can substitute for fossil-based energy sources or fossil-based products like steel and concrete. So we include the entire systems approach so we can calculate the mitigation potential. And we do this relative to a baseline, so a business as usual activity. And we want to include mitigation activities that are incremental, that are based on a change in behavior or technology. So how many mitigation options do we look at? Well, many. There are many different interests for the forests. And so we want to look at different options and use the same modeling frameworks to compare them and contrast them. So I'll just walk through all the mitigation options that we looked at. I'll remind you that we had a baseline, which is looking at the forest ecosystem with projections of harvest and slash burning, and also some simplified estimates of wildfire into the future. And so we took a business as usual, and then the incremental activities added on. The first one looked at higher utilization of harvest. So right now you can capture a certain amount of the stem wood for harvest and take that wood out of the forest and transfer it to products. And we said, well, what if we increase that capture percentage? And that means leaving less waste in the cut block, so there's less harvest waste. And we use that wood for products. And we also decided to increase the salvage harvest percentage. So you can harvest live trees and you can harvest dead trees, and you can make wood products out of both. And so we slightly increased the amount of salvage harvest that was going on. And both of these activities mean there's less harvest of live trees, so there's more forest area left behind to continue growing. The second option that we looked at also dealt with harvest residues. And there we decided to capture the harvest residues and use them for bioenergy. So we would take the residues off-site, grind them, and create heat or electricity with stationary combustion. And as a result of there being less forest residues, it requires less abatement of fire risk, so less slash burning emissions. Then the third strategy was to combine these two activities. So they both deal with residue management. So one you can turn into products, one you can turn into bioenergy, or you can do a little bit of both. And so we added those two together. Then the fourth one looked at harvesting less. So we just reduced harvest levels 2% across the board. And then we added a restricted harvest scenario where we did not allow the model to harvest stands that were older than 250 years old. Now these are all forest management options. We can also look at a wood use option. So it doesn't change the amount of harvest, it just shifts the commodities. And so we looked at increasing the amount of longer-lived wood products. And by that, we took a small shift, 4%, and we said we're not going to make pulp and paper, which we model as a 2.5-year half-life. We're going to make panels, and that has a 25-year half-life. And when we make panels, we can substitute for fossil products like steel and concrete and put it into buildings. So I'm going to just jump into the mitigation results. I do want to tell you that at this stage, we're looking for feedback. We're providing information on the assumptions and the results, and we're looking for feedback. We know there's things that can be tweaked and changed, and we want to work on those. And we're looking for input. So please, give us anything you're really looking for. Now on the left, typically what you see presented is for greenhouse gas mitigation is an annual emissions reduction, and there'll be a baseline, and then there'll be a mitigation scenario. Now the forest can be a source or a sink, depending on what the disturbances are. So these tend to be quite noisy. So what we do is we subtract the mitigation scenario from the baseline, and we tend to show it as a cumulative mitigation on the right. And this way we get rid of a lot of the noise in the background signal, and we're really picking up the impact that is only related to the mitigation activities. So you'll see graphs that look like the right, showing the cumulative mitigation over time. So this shows the results of the modeling. It's the cumulative mitigation with the difference between the scenario and the baseline. And we started our mitigation activities in 2017. And so the first thing to notice is there's a wide range of climate change mitigation potential. And it really does depend on the strategy or the combination of strategies that are included. So some strategies we found had a negative mitigation potential. So that would result in an increase in greenhouse gas emissions if they were implemented in some regions. So this graph shows the result of applying the scenario to the whole province, regardless of whether that mitigation would be positive or negative. But that wouldn't really happen. You wouldn't implement a mitigation activity if you knew it was going to increase the greenhouse gas emissions. So we can filter out the regions where the mitigation potential is negative and only consider regions where there's a reduction in greenhouse gas emissions. So this shows the cumulative mitigation in megatons, or millions of tons of carbon dioxide equivalent for the year, and it's the incremental activity that's been applied for the scenarios. And here I've started to play with combinations of scenarios. So it has a forest management scenario as well as a wood use scenario. And you can see there's still a wide range. You can have restricted harvests with more long-lived wood products. You can have harvest less, and these have some mitigation potential. We found that residues for bioenergy has kind of in the middle response. And then we found that some of the higher strategies were really combinations of activities that worked really well in some regions. Now you can say, we know there's not going to be a one-size-fits-all. We know there's going to be different regions that are going to have different strategies that can really optimize the mitigation potential. And so we developed what we call a portfolio of activities, and this selects the best scenario or combination of scenarios for each region, and then puts them all together. So we can maximize the mitigation potential for the province. And so that has the highest mitigation potential. And it was about 449 megatons in 2050. That's the cumulative mitigation. Now this includes wood that's cut in BC, and it can be exported and includes substitution in another country. And so we said, okay, well let's limit it to what can be done in BC. And so if we say, okay, we only want to know what BC's mitigation potential is, we still consider the harvest that occurs, but when it's exported, we don't get a credit for using wood instead of steel or concrete in another country. We'll only look at what happens within BC. So this is what the portfolio looks like for BC when we maximize the mitigation potential. So the efficiency of the mitigation options varies by activity and by region. And we are doing analysis at the forest management unit level, and they certainly vary in size and harvest levels. But what we see overall is that the best combination strategy for most places involves higher utilization. So if you're going to cut it, you got to use it. It looks at using the residues that are left behind for bioenergy, for stationary heat and electricity. And it involves shifting the commodity mix away from pulp and paper, a short-lived product, to panels, a longer-lived product. In some regions, the use of bioenergy can't always substitute to high emissions fossil fuel. And so that in the purple region just shows the higher utilization as well as the longer-lived wood products. The other strategy that comes up is the restricted harvest. And we modeled that as not allowing the model to harvest stands that were older than 250 years old. And you tend to see that come out on the coast. Now, these results do not yet take into account the environmental sensitivity, the changes in the growth and mortality that Robbie will talk about next. So we are working on including those in the analysis. So I'd like to kind of put these numbers in context by comparing them to BC's greenhouse gas reduction target. So the target is an 80% drop in the greenhouse gas emissions relative to 2007 levels. And so this is, it works out to about a 52 megaton drop that has to be achieved in 2050. So we asked, what contribution can the forest sector mitigation make to this reduction target? And so the portfolio on the far right shows that if we combine activities and choose the best options for each region, we can contribute about 35% of the mitigation reduction target, so about 18 megatons. And as Werner mentioned earlier, we tried to partition the mitigation potential into where it's occurring. And part of this is so we can assess what the uncertainty and the risks are in each of the activities. So if you look at the portfolio bars, you can see there's quite a large credit in the forest ecosystem. There's a debit in the harvested wood products, and then there's substitution benefits from energy. And so I just want to take a couple minutes and just explain how those bars come about. And I have included all of the scenarios and their combinations on the bottom, but I'll just highlight a couple that are interesting for the portfolio. So one of them is the higher utilization scenario, and it can contribute about 16%. And you find this credit almost entirely in the forest ecosystem. So this strategy didn't change the amount of harvested wood products, so there's no impact on the harvested wood products emissions or displacement. Really what it did was create the same amount of products using some of the residues that would have been left behind as waste and would have decayed or would have been slash pile burned, and we created products out of them. It also increased the salvage harvest, and the end result of that was avoided emissions from harvest as well as an enhanced sink from the forest that was left behind. So that is a forest option. That option really comes out in the forest ecosystem sector and is vulnerable to risks of reversal if some of those trees aren't able to be a sink. We also have included the bioenergy strategy, so the residues for bioenergy. And this one has some interesting positive mitigation and negative mitigation. And really, in this case, we're taking something that would have been emitted in the forest, residues that would have decayed or been slash pile burned, and we're transferring them to a bioenergy facility. So there's a positive in the forest, a corresponding negative in the harvested wood products modeling. And they roughly would cancel out, except we have a big substitution benefit from avoiding the burning of fossil fuels. And to get that substitution benefit, you have to avoid burning the fossil fuels. So that's where the uncertainty would lie for that scenario. And then we have restricted harvest here. Restricted harvest shows a reduction, a mitigation in the forest component as well as the harvested wood products. And we found that where this strategy tended to be positive, there just wasn't a lot of young stands available to harvest. And so it turned into a harvest less scenario, quite substantially less in some cases. So there's less harvest. It means there's a credit in the forest. It means there's a credit in the harvested wood products. We did assign a penalty in the displacement, because if you're not using wood, you have to use another product. And so there's a negative product displacement that comes in there. And then the longer-lived wood products, you get reduced harvested wood products emissions and a credit for increased substitution. So when you add these components together, you end up with the portfolio mix that describes where the credits and debits will be coming from and what the total mitigation potential could be. Okay, that's the end of part one. I'm going to hand it over to Zach now to do part two.
Good morning, everyone. So following the biophysical GHG or carbon benefit we just discussed, we also look at the cost and or economic impact and the socio-economic impact of the options. So the first thing we look at is the total, the total mitigation cost. So you can see from the graph that for some of those options, like the high utilization, harvest less, and restricted harvest, cost a little bit less. It's about less than 100 million per year. That's the annual average. And some others, like the long-lived wood product, so there's a mistake. There should not no W there. The long-lived wood product and the combinations without bioenergy, a little bit higher, 100 million to 200 million per year. And then all those combinations with bioenergy and the bioenergy options per se has a little bit higher cost, from 200 million to 500 million. And then the portfolio, of course, has the highest cost, up to 610 million per year. So I want to make sure that everybody understands that the mitigation cost here is the change in the total net revenue among the relevant industries in BC. So it's the impact of the implementation of the mitigation options on the industry. So there's nothing related to any investment money or like the amount of cost that any organization or agency should invest. That's just the pure economic estimate of those impact. So, and then we estimate the average cost per ton to combine the cost and the annual mitigation impact into one single index. So if you look at the graph that we map all those options into a graph that's showing those cost per ton values against the annual average domestic mitigation. So the purpose of this graph is show this cost effectiveness of the strategies. So from the higher left to lower right, so we can see the strategies goes more and more cost effective. And the portfolio, of course, is the most cost benefit options we have, and followed by those different combinations. And those single or individual mitigation options show a little bit lower cost effectiveness. So in addition to those combinations, in addition to those comparisons among different options, we also have the curve called the cost curve to show the variation of the cost effectiveness for each mitigation option over the different spatial units. So that's the example of the cost curve for the portfolio. From the lower left to higher, right, we can see there's more mitigation and, of course, higher cost. So the line is not smooth because each line segment represents the mitigation, the annual mitigation at a certain cost level. So, and you can see that through the portfolio cost curve, we can achieve more than 12 megatons on average per year at a cost of up to $150 per ton. And 85% of them can be reached under $100 per ton. And then last, we show the cost curve for the same option but with different time period. So that's the example of the portfolio. So that's the, if you want to maximize the domestic or the BC mitigation potential, but in different period, you can see that if you want to do that in 2020, it's going to give you almost nothing. But if you want to consider the long term, it gives you much more mitigation options or mitigation potential at the same cost level. At last, we estimate the socio-economic impacts by looking at those impact of those strategies or portfolios on employment, on GDP, and government tax revenues. And why we're going to do that? Because that's a necessary complement to assessment of these mitigation costs for policymakers. And how we do that? We just use the multipliers in the input-output model from Statistics Canada to estimate those the socio-economic impact for each portfolio, each option. And the key message from those analysis is that by implementing the portfolio for the longer term, BC can create more than 2,000 new jobs and about 284 million per year for GDP and 34 million per year for the government tax revenue. And that includes all the government levels. Well, of course, that's the average value. So the key message of the presentation, of course, we need to consider a system approach to include the forest ecosystem, harvest wood product, and the substitution effect. And then we need to consider the efficiency of the mitigation options across the region and carefully ranking the mitigation options over time because they vary over time. And then forest managers do not control the use of wood, so we need to always combine the forest management with the wood product strategies to make sure we get the best potential. And then we also prove that the portfolios or combination of the strategies can achieve more mitigation at a lower cost level than individual strategies. And options are more cost effective in the long term than in the short term. So the forest sector mitigation could contribute more than 1/3 to BC's emission reduction target at 2050 at a cost of less than $100 per ton. And by by using the domestic portfolio, we also achieve a lot of socio-economic benefit. And the last one is, of course, the scenarios we are considering right now is a little bit conservative, and we believe that the actual mitigation potential may be substantially higher. And we also be aware of that there's barriers of implementation and costs, and that could lower the mitigation potential in some options. So that's all the results we have so far. Thank you.
Why don't we take the next few minutes to take questions from the audience initially, and then if there are questions online, we'll also answer those. And so please go ahead if you have any comments or questions. Please bring those up. And maybe what I'll do is I'll bring up the slide that has the email address. So let me find that.
Test.
So for those online, they can ask, oops, sorry, that's not where I want to be.
Thank you.
Against.
Thanks. This was, again, a very enriching learning experience. I have two questions. One question is, in how far were you able to consider in your scenarios the risk of increasingly severe climate impacts on our forests in the next 40 years, looking at the 2050 years, the risk of more fire, more insects, and so on? And the second question is, so the recommendations the portfolio makes sense to me looking at BC's, the vast majority of BC's ecosystems. I'm glad to hear that you're looking at the different regions. I'm convinced that's very important. I'm glad to see that 250-year-old forest is considered as important. I wonder whether there could be more work done or different approaches to really identify this relatively small subset of forests that is characterized by very high carbon storage per hectare, low disturbance, where we have to expect a very significant initial carbon loss if these types of forests that have been undisturbed in many cases for hundreds of years are being clear-cut, where we don't have a recovery of the carbon storage for many decades. And I was wondering whether it would be meaningful to look at, instead of 250 years, at carbon storage per hectare. These are usually temperate rainforests, like looking at 500 tons per hectare or 1,000 tons per hectare. I'm not sure what would be the best value, but that way maybe it's better, it's even easier to identify this subset of forests, where I think of these similar, like some climate experts refer to unburnable carbon, looking at some looking at some fossil fuel reserves, but I also think there might be some forests out there that should never get logged because we really need them to keep the carbon on the ground. Thanks.
Yeah, thank you. Let me start with the last one. Carolyn and Zach spoke about the what we call a restricted harvest scenario that was actually implemented in response to a request from one of your colleagues. And it's generated a lot of discussion and will clearly generate more work. One of the questions that we have been asked and that we need to revisit in our future analyses is why 250 years? That was clearly a number influenced strongly by coastal thinking, because in the interior, old growth forests considered old growth could be 150 years old or 200 or whatever. So that number is something that we need to revisit and develop more regionally differentiated approaches to that. I like your suggestion about a carbon threshold as an alternative. But there's maybe a different way, yet another way to look at it, and that is sort of the, and I don't have a term for it, but the proportion of the carbon that is in the forest that can actually be utilized. Because if you have a second growth stand, 80 years, 100 years old, much of the carbon that is in virginable timber can actually be utilized in one form or another. Whereas in an old growth forest, you can have a lot of damaged material, rot, wood with interior rot, etc. And so as a consequence, while the value per cubic meter may be higher, the proportion of the carbon that is stored there that can be used can be much smaller. So there are ways in which we think we need to explore this further, different age criteria, carbon stock criteria, maybe even other things like the index that I just tried to develop in terms of the proportion of wood that can be used, etc. So clearly an area that has a lot of interest. The other point that you made about the regional differentiation, yes, we look at that and have looked at that in the province. There clearly are huge differences in terms of growth rates, decomposition rates, risk to disturbances, etc. across the province, but it's also a fractal problem. As you change your scale, you see similar diversity emerging, right? Even within one of those management units, you have forests that are on the top of a ridge or at the bottom of the ridge. They may experience very, very different susceptibility to climate change, to drought, etc. And so this thinking about every stand has a story, somebody said yesterday in a stakeholder workshop, really much of forest management is site-specific. And so part of what we need to do is collectively develop the know-how and the ability to think about these decision-making processes in such a way that carbon and other indicators can be taken into consideration. Foresters are already doing this when they do silvicultural prescription, site prescription, etc. What is new is that now, in addition to habitat and many other criteria, they need to also start thinking about carbon in a way that is not normally trained at universities or hasn't been trained when many of us went to universities. And then the first question that you had was that of disturbances. And I think that's a very important aspect. We have not, in this particular analysis, dealt with it yet. It is work that we're planning to do in the remainder of the year of the project. But we have done earlier work, and there are a number of publications from the team over the years that have highlighted the nature of the stochastic disturbances and the problem that all you can predict for the future for a specific region is a likelihood of disturbances occurring. Whether a disturbance of a wildfire will occur in 2030, 40, or 52, cannot be predicted. But you can develop what are called probability functions of disturbances occurring. And we have done those kinds of analyses. The problem then becomes that you, instead of getting an answer, you get a distribution of answers that depends on the likelihood of certain outcomes. And so what we have not yet done, but need to think about, is how do you combine these probability distributions with different mitigation scenarios? Because now you're looking at two sources of noise. And what Carolyn was describing, when we take a baseline and a mitigation scenario, we would then have to apply these disturbances to both and see what the difference is between the two and how and if the ranking of alternative changes with this disturbance risk. Carolyn alluded to that briefly when she, in the bar charts, spoke about the uncertainties and the risks of each of the components. If you have a substitution benefit, then that is something that has happened. It's an avoided emission. You can book it or keep track of it, and it's not reversible. Whereas a carbon storage in a forest, if you have that fire risk that you just described, or insect, or any other form of disturbance like drought that Robbie will speak about, then you have that risk of reversal. And so as we go forward, we not only need to look at what are the strategies, but what are the likelihoods of outcomes, and that is influenced by those disturbance risks. Any other questions?
Mine's not so much a question than can people hear me?
You need the microphone because you're on the webcast, so others won't hear you if you don't use the microphone.
Just a caution on lumping pulp and paper together. Paper
Yes.
In the province is all made domestically. It uses local energy sources, so it has carbon low levels. Pulp is 100% exported.
Yes.
One of the characteristics that BC fibres, particularly the interior fibres, have because of the climate is it's very easy to refine. And refining is the most intensive part of paper making. So if we produce 2%, 3% less pulp for the world, there will be emissions somewhere else in high carbon generating areas.
Yes.
So, but keeping pulp and paper separate would avoid that. So just a sensitivity.
Yeah, that was more sloppy language than anything, and of course, having a lifetime of experience in that sector, you call it. It raises a bigger issue, though, and that's another area where we are contemplating further research, and that's this whole question of leakage, right? So if we make a decision in British Columbia to do something differently, what are the implications of that in other regions of Canada, of North America, of the world? And so we spoke a little bit, about domestic versus global substitution benefits. We only look at the domestic substitution benefits at the moment, but this question of how will the rest of the world respond is something that we have not yet looked at in detail. We make certain assumptions about if you harvest more or less product, then you have corresponding implications in other sectors. And we currently assume that if you harvest less, it means other products may be used, like steel and concrete. But of course, it could be that somewhere else somebody harvests more with the corresponding impacts on greenhouse gas emissions. Now, they will have the same direction of the impact as using steel and concrete, so at least they're not offsetting each other, but that may not always be the case. So this is some area leakage that the response of others is something that needs to be looked at in more detail. But this is really the first time that this kind of work is done. This team's effort over the last 5 years is really the first time that this kind of work is done in Canada, and we're working, of course, with people around the world on these kinds of things. There's, okay, you go first, and because you're closer to the microphone, and then we'll pass it up to you.
We have also questions online.
Okay. Yeah. What I thought we'd do is maybe go till 10:30, so 10 more minutes, and then we'll take a break, maybe a compressed coffee break, and try to catch up with things. Okay. Go ahead.
Good morning. Great presentations. Thanks for sharing the data. I'm curious, looking at the cost curve and seeing that bioenergy was at the higher end of the range. I'm curious, is that because a lot of slash is just uneconomic to retrieve and utilize? And if that's the case, are you pointing to incentives to utilize that bioenergy or that biomass for bioenergy potential?
Yeah, good catch. So actually the bioenergy is expensive in our analysis because in most cases the bioenergy is replaced for those cheap natural gas energy. And in some remote areas we need to consider those options. And so if you consider those substitution effect plus those transportation from those remote areas to grab those fiber out to the bioenergy facility, it is expensive. Also, we need to consider the construction of the bioenergy facility. That's the one-time investment, which is huge, I guess, as well. So, yeah, that's, I guess, the main idea of those costly options. Yeah.
Thank you. Oh, sorry. Yes.
I'm really excited about some of the options here, but I just was hoping to suggest that we potentially look at going outside the sort of business as usual model in terms of the forest ecosystem management dynamic that's going on in British Columbia right now. For 20 plus years I was involved on a very ground level alternative natural selection forestry model up in the Quesnel area that would blow these numbers right out of the water in terms of employment intensity, low-grade natural selection forestry, supplying or creating a value-added silvicultural system that could supply a much longer-term value-added manufacturing sector, building instruments and furniture and all these kinds of things that would lock carbon up in quality products for much longer than anything that's held together with glue. So I would really like to see potentially some of that come within these discussions, looking at really the best case scenario when we break out of business as usual silvicultural, the classic, short rotation fiber mining, and move to something that really could propel those alternative silvicultural systems into something that could really have amazing numbers in terms of this.
Yeah, thank you for making that recommendation. And you heard that Zach, I think it was in the presentation, commented on the fact that these scenarios that we have developed were done with stakeholders involved in the process, but also, of course, the provincial government, industry, and others. And initially, there has been a very conservative approach to these things. We move the dials by small amounts to see what the impact would be. And we are involved in stakeholder consultations. George, we just did one in Nanaimo yesterday. Prince George, Kamloops, and Vancouver are on the list. So Canal, maybe you can scoot over to Prince George. Okay, great. And so I think it is really, really important that the public of British Columbia, we all understand, that we own the forests. 96% of the forests in British Columbia are Crown-owned. And I will talk in the last presentation about the next steps, a little bit about developing a vision. And so what I think is really important is that as we think about how can our society go from where we are today to a minus 80% reduction in emissions, we will need to fundamentally rethink how we do certain things. And what you listed, for example, I think is a very viable, possible way, community-based forestry, more intensive management. And intensification and enhancement of management doesn't mean, industrial monocultural plantations. We just have to go to Europe and look at, mixed wood forest management, enhancement of productivity. There is so much that we can learn from Sweden, from other Scandinavian countries, from Germany. And I think we just need to create a vision of these kinds of things also being possible in British Columbia. We don't have to do things the way forestry was done here in the 70s and 80s. As we go into later in the century, there are other opportunities, and they involve greatly enhancing carbon sinks for the benefit of people not only in the rural communities, but also in the urban communities. There was one more question here a moment ago, and then we'll go to a couple of questions online. Who had the question? Yeah, go ahead.
I actually had a question pretty related to the previous one. One of the mitigation strategies that looked pretty promising was higher utilization, both for costs and in the sheer amount it could mitigate. I was wondering if the cost estimate for that is based on current conditions or looking forward. And the reason I'm curious is it seems like the trend right now is to leave less wood in the forest, especially as the good wood becomes less accessible and there's more hella logging. The amount of waste is pretty astonishing sometimes. So I'm wondering sort of how you guys calculated that based on current conditions or looking forward.
Yeah, the cost of that option is based on the current conditions because you can see that the cost of this high utilization option actually is negative, which means we can gain something from it. But that's based on the assumption that in order to get the same harvest volume, we reduce the harvest area. So that means we have less cost on the road construction, on the movement of those equipment, that kind of thing. But also there are some other considerations, like we probably need to face the higher cost of the inferior log quality harvest, and the use of those wood will cost a higher unit cost. So that this combination of different considerations of those options for the cost, so that the result you saw is kind of a combination, like the combined effect of the different reduced and increased cost of the current conditions. Yeah, thanks.
So we'll just go to a couple of questions from the webcast.
Okay, so this comes from Gerald Joe. Have you adequately reflected rapid technology advances that will significantly reduce the need for forest products and the amount of excess carbon dioxide in the atmosphere? For example, a company, Global Thermotest, has an industrial-scale process to take CO2 from the atmosphere to make products such as plastic and carbon fiber at the point of manufacture. In particular, this carbon fiber could be used to make buildings, bicycles, cars, etc.
Yeah, so that's a really good question. And I think we all need to understand that as the world is seeking a solution to climate change, we will see technological innovation. We will see opportunities to remove carbon dioxide from the atmosphere and turn it either into a liquid that is pumped underground or into a product. There's some really exciting ideas around taking carbon fibers and making rods that are equivalent to reinforced steel that can then be inserted into concrete. A lot of these processes are, of course, very energy intensive, and I am hugely supportive of all efforts to try to reduce carbon dioxide in the atmosphere. Every analysis that I've seen to date indicates that the scale at which this can be done is relatively small at the moment. The cost per ton are very high. And why would we go through an elaborate process of trying to reconstruct something that can hold strength or avoid compression when we have wood to achieve the very same outcome already? Often at per pound, wood is stronger than steel. And so we have materials that are renewably constructed with low energy that can serve these purposes. That doesn't mean we shouldn't try the other things. We absolutely have to. Anything that we can do to remove carbon dioxide out of the atmosphere, but the scale at which this can be done globally and the scale at the cost per ton is at the moment not such that we will solve the problem with it. And then you had a second question?
Yes, there is a second question. This is coming from UMBC. We have a satellite room over there. So were you able to, at all, to consider market demand in LLPs? Is it realistic to assume that we could sell 4% more panels in your example?
Yeah, so I think there are two things that work together. Market demand is partly the result of consumer awareness and willingness to recognize the environmental benefits of using wood over more emissions-intensive materials. But it's also aided by technological advances and building codes. So governments can play a role here. British Columbia, Gordon Campbell in 2008 introduced a wood-first policy for publicly funded buildings. The building code change that has already occurred to 8-story buildings. And there are other efforts underway. There are already movements towards a national building code to 12 stories. And in fact, in the United States, they're speaking of 21-story wooden buildings as part of the building code in the coming years. So this is not happening overnight. But what is happening is a growing awareness of the ability to construct with wood in a way that was not conceivable even a few years ago. And so I think the demand for these products is easily created. I don't see that as a problem at all, as long as the regulations are in place, it's cost effective, and it's, from an engineering perspective, a sound solution. People certainly like living in wooden buildings more than in a concrete building.
Yeah, I think just building on that, what we're trying to encourage is a longer life in the wood product. So if we can make a structural product out of smaller pieces of wood that can displace steel and concrete, if we can use the existing lumber that's now being used and create CLT and make 18-story buildings, that's the best option. Yeah. And then cascaded wood use after that. So after you're done with whatever it is, 75 years from now, you can no longer use it in the building, then make something else out of it, or use it for energy and displacing fossil fuel. So always have the next use in mind whenever you're creating something. Yeah. And certainly make good, long-lasting wood products, whatever you can.
So thanks for the excellent questions. I'd like to take a quick break. Why don't we get back here at 10:45? That gives us 13 minutes. But please be ready at 10:45 so that we can resume with the presentations and webcast. And then there will be a second round of questions at the end, and we can continue the discussion after the session is over also for a few minutes if people are interested. So thank you very much. Now we'll give a 3-minute warning before the...
There are some refreshments outside, so please go ahead.
Just introduce you to Leith McKenzie.
Yeah, well, wait. Okay, now we're off. Sure. Okay. Yeah. Okay.
Can you funnel some people into me? Can you funnel Rod and Guillaume and George, I think Robbie in particular wanted to check his presentation. Guillaume and George, maybe okay.
And so quite short, which is problematic. In terms of the debriefing, Jack's like, yes, I know.
Yeah, you could
Right.
basically.
I can look at George through it.
Okay, I got both there. Did you know which one you wanted to use?
Use
It's
that
too
one.
bad there's no printer.
Yeah, and no
It's doing
clicker.
The man in white thing.
Yeah. Yeah, that's good. Works.
Okay, and if,
So there's no
tell
clicker.
George this, because Werner, the light hit him. Yeah, so I'm short enough that I didn't impact him.
Yeah,
But I'll ask
good
him
too.
to move it up and over a bit so that when he comes back.
If there was a clicker, we could just.
You could, first of all, you could ask. I'm assuming they would have used it already, but you can still ask.
I'll ask.
It's all gonna work. Yeah, exactly. So what I was able to do is reconfigure it to use the default main page. Quickly, so I would email back to the office and have a link to the main page as well. So a couple things generally to catch. One, the laptop with the presentation is detailed drives. Resets to the PowerPoint version.
Hey, Guillaume. Is our presentation consolidated into the same file? Where's mine? Do you know?
So yours is
Now that hardest system costs a couple dollars more.
I'm David, I'm so sorry.
you don't have a clicker.
But we can also, if we change the policy a little bit, we can probably plant all this area.
Yeah, I want to get rid of this slide.
Your artist from having
Delete or
No, just hide it.
other
When we arrived at 7:30,
or encourage others to have the word we could be.
until
So my question to you is that something.
Do I go before you?
Yeah.
40% of our
then there,
more how
You have to choose between this or.
broadcast different.
5 minutes before we were ready to go. And it was much more comfortable to have a laptop here and read it. And if that hadn't been
might be using?
I'm flexible. If you want to, actually, it might make sense if you put that on so you're prepared not to use that one. Or we can just switch it up, doesn't matter. I think the red button turns it on.
I don't want to use that.
I'll use it. Am I going first?
Well, this is my legacy forestry project. I'm not sure what I'll do after this. Actually, that's the thing I like about the entire job. Right now, they created all these Steve, so 2.5 horsepower last year, were ran out. Couldn't get a lot of time over This is what you guys let's talk. Please share your experience and your knowledge.
Perfect. Yeah.
We're going to get started here, so if you can take your seats, please. Yes, I have
Can everybody hear me? Is this live? It's live? Okay, perfect. So thanks for joining us. My name's Robbie Hember, and I'm going to present an overview of the research focusing on involved in theme 2 of this collaborative project involving environmental impacts on forest productivity in British Columbia. So this morning we heard about efforts to develop mitigation portfolios that are aimed at keeping carbon out of the atmosphere using forest management. And theme 2 follows from that with the recognition that we also need to be concerned about how the climate system and environmental changes generally will impact forest health and productivity, and how that will influence the effectiveness of these mitigation portfolios. So one of the first things we did was developed a big picture summary of what we think the environmental impacts have been on forest growth and mortality. And we did this nationally using field plots collected by provincial agencies and industries across the country. And we used that data to develop statistical models that relate environmental variables against forest growth and mortality. This is one of the biggest studies of its kind. We were able to use over 37,000 measurements in British Columbia and over 60,000 measurements across the rest of Canada. We summarized our results at the level of ecozones, so calculating ecozone average time trends in forest growth and mortality, and a lot of effort was put into specifically attributing the component of those trends associated with environmental change. What we found is that in the humid ecozones, for example, on the west coast of Canada and other humid ecozones, we estimated significant positive trends in growth or growth enhancement. However, we also found that in the drier west central ecozones of Canada, that the growth enhancement was substantially muted or even canceled out. And then for mortality, we found pretty much the opposite pattern, where there wasn't much of no significant time trend in mortality and significant increases in mortality in the drier regions. And so a major conclusion for British Columbia is that there's weakened growth enhancement in British Columbia's interior regions and also increasing tree mortality. So that's a great big picture summary to have. But forest managers and carbon cycle modelers require much more detailed information about environmental impacts, in particular on specific commercial tree species. And we've already touched on how important the site variation is. So in a more detailed study, we focused on the issue of drought-related tree mortality. And in this particular case, what that involved is taking all the data for a specific tree species, and we did this for many species across North America. And for each species, then developing what we've referred to as drought vulnerability curves. And so these simply relate the probability of tree mortality with common hydrological variables. And that allowed us to investigate some important covariates, other factors that tend to influence the vulnerability of a tree to drought. For example, we found that the size or the height of the trees has an important influence on the vulnerability to drought. And we also found things like the location of that tree within the species distribution can also mediate its vulnerability, implying a certain degree of genetic variation within the species. So that's the kind of information we really need to know confidently in order to design mitigation portfolios that target locations that we know will have high productivity. When we take all those species and summarize what happened to the probability of mortality over time for about 6 decades over the historical period, what we found is that the probability of mortality has been increasing over time, and that it's not just an increase, a gradual increase in the background rate of mortality, but it's also an increase in the frequency and intensity of these extreme mortality years, which are attributed to extreme regional droughts. And these are areas that we think are very important for capturing this level of mortality because they likely devastate the forest in a specific region, and that has carryover effects for the forest sector for decades. So we also, in addition to things like drought-related mortality, need to consider positive effects of various global change factors. For example, increasing carbon dioxide concentration would be one of those. Carbon is a primary building block for plants, and they get that carbon from the carbon dioxide in the atmosphere. And so it's been long hypothesized that the increasing CO2 in the atmosphere will enhance the growth rate of these trees. So we did this using statistical models, and this is a comparison, the green showing our results developed from statistical models that are fitted to observations in the field over the historical range of carbon dioxide concentration, showing the relative response to CO2, compared with a compilation of experimental findings from other studies that have enriched trees with CO2 at a much higher level. And what we find from this is that there's a very good consistency between the two independent sources of evidence. And there's two major findings here. They're consistent in that, on average, the growth rates increase with increasing atmospheric CO2. But both lines of evidence also suggest that the variation around that mean, the shading around those curves, is gigantic. It's greater than the mean itself. So we really, to have any success at this, we need to understand why that is and be able to predict where CO2 is going to have a positive effect and where it's not going to have a positive effect. And that kind of information is pretty powerful. So we had more data than anybody has previously had to look at this question, and it afforded us the opportunity to break down, looking at those statistical models in more detail, to break down the area for any given species, to look at the area where CO2 is having a positive effect and where it's not having a positive effect. And if we look at that area to understand where CO2 is not having a positive effect, to understand in more detail why, what we find is that there's all sorts of reasons to explain why. Sometimes the temperature is too high, sometimes the atmosphere is too dry for that species, or it's too humid for that species. Sometimes the soil water is not optimal, and sometimes the nitrogen is not an adequate supply to support further growth enhancement. None of this is incredibly shocking to people, for example, in agriculture. They've kind of known this stuff for decades, but quantifying the effects and mapping it for commercial tree species remains a major challenge. Basically because even though we have lots of data to work with, it's probably, it certainly needs to be increased and sustained into the future to constrain these kinds of numbers, and in particular to put a face on this by mapping it across a species distribution. So that's an example of one of the global change factors that we need to consider, and we need to consider it because it's happening everywhere. So the magnitude of the impacts on forest productivity are huge. But forest managers also require information pertaining to local scale variation and growth. So within a forest management unit, we know that the aspect of the terrain can have a major impact on forest productivity, and elevation can have an important impact. And as simple as that sounds, modeling this level of variation can be a challenge. So we have been busy trying to incorporate not just global change factors, but also this local scale variation using terrain variables at a high resolution. And when we do that, we have a fair degree of success predicting growth rates and how they vary over local scales. So this is a nice aerial shot of predicted growth over the Fraser River Canyon in central British Columbia, showing the differences between high growth rates in the valleys and low growth rates towards the tree line, or towards the forest grassland ecotone. Okay, so just to recap, we've developed a big picture summary of what we believe to be the environmental impacts on forest growth and mortality. We did that at the scale of ecozones, and we did it based on observations, which is fairly rare in our field. We secondly have started to advance the capacity to predict environmental impacts on trees, addressing these key questions facing British Columbia, for example, the drought vulnerability of our species, the impact of global change factors, and local scale variation. And just to finish it off, we'll look at our current, moving forward, what our plans are is to try and bring all of this together. That is combining environmentally sensitive, species-specific models of growth and mortality to incorporate that information into estimates of the long-term changes in forest biomass in British Columbia. So this is an example of the simulations we're starting to do, looking at stands leading with lodgepole pine and the types of simulations we get out of this, trying to achieve a more complete expression of forest health indicators by combining information on stand replacing disturbances that are provided to us from forest inventories with a certain amount of tree mortality that needs to be modeled. So these are partial disturbances that can have a huge impact, but are still very hard to account for in our models, all the way down to the background rates of mortality, which also could have fundamental influences on future plans if they were to shift by even a small amount. And then finally, using that information, incorporating that information into the carbon budget model to predict the forest carbon cycle within a probabilistic framework that accounts for variation in future emissions scenarios, variation in climate change, climate model simulations, and variation in ecosystem responses or the behavior of tree species. Thank you very much.
Does that work? Oh, I have to find my presentation. I feel like saying it now for something completely different, but maybe it's not. I'm a political science guy who does policy work, so my approach to this is different, and I just want to give as an overview a couple of things. One is that the modeling analysis that was presented before the break suggests enormous potential for carbon mitigation in the forests at costs that are cost effective. But that is based on an assumption that that's feasible and that's somehow the policies and practices need to change dramatically in a way that's feasible, credible, and legitimate. And we haven't done that sort of analysis yet. We're really just beginning that. And I also want to note, I've been studying forest policy in British Columbia for a couple of decades now, and one of the things that we talk about is the relationship between broad public values and public policies and the way we manage our forests. And values in society change. In the 1970s and 80s, we had a huge shift in British Columbia away from values about production only to ones that took into account environmental values more seriously. We're now experiencing another fundamental change, and that's towards the relative importance of carbon and climate issues in the forest as part of that broader environmental envelope. Policies frequently lag behind those changes of values, and we're at that stage now where policies are lagging significantly behind, and hopefully there'll be, with the exciting new governance situation that we have, an opportunity to dramatically ramp up a convergence between where we're at in terms of our value set and where our forest and climate policies are. We really do face some quite different kinds of choices about how to approach this policy-wise. We could continue to do what we're doing with some elaboration by relying on forest carbon offsets. That's the one at the bottom there. We could go out and spend money and invest it directly, take public money and invest it in the forest. Or we could change policies to require or incent these sorts of greenhouse gas reductions. And I'll give examples of each of those. And starting with offsets, because that's really our contemporary framework. And what we do with each of these is we go through what the current status is, whether there's some kind of a gap there, and if so, what option exists to see if that could be filled. We have this requirement for carbon neutral government in our province that has provided a regular market for forest carbon offsets, but it's quite a small one. The new regulations have been put in place to provide for the LNG industry, GERCA, it's too long an acronym for anybody, but it would basically provide a significantly larger market for offsets if there's an LNG industry that emerges in the province, and if the way they choose to get their greenhouse gas reductions is to invest in other people's projects as opposed to doing it within their own site. We'll see if either of those things happen. So even if that does happen, though, there's still a limit on the size of the offset market, and one option that the province has is it could partner with other jurisdictions in Canada or North America or globally to be part of a larger cap and trade and offset system where we could have a much larger market for offsets. The accounting for forest carbon is remarkably complex. And in British Columbia, we have gotten very good, or relatively good, at measuring carbon flows through the forest and through wood products, and we display those publicly. But in terms of our actual accounting, what we count towards our legal obligations to reduce emissions, we only count a very small fraction of the measured anthropogenic forest emissions. And one of the things that we could do, if we wanted to, is we could change that. We could change it to move more into accordance with international accounting norms so that we count that stuff as part of reductions towards targets, and that would create an incentive for all actors in the system, government, industry, and others, to create policies and practices that bring us more into line with our legal reduction targets. So that's one kind of instrument, how we choose to account for things. We're famous for our carbon tax, a fiscal instrument, currently capped at $30 a ton. We all kind of know that's going to go up, again, especially with our exciting new government arrangements. I shouldn't say exciting. I don't want to. It is exciting because it's so new and different and unconventional. But we're $30 a ton. It does not cover forest emissions. It covers fossil fuel emissions from logging trucks, but it doesn't cover emissions that come from all the sorts of things that you heard about before the break. It would be very complicated to figure out how to apply that across the board, but a more modest thing you could do is the stubborn challenge of slash burning in the province. We could tax the emissions from those and potentially create a significant disincentive for something that has been a significant challenge for the province for quite some time. So those are a couple of, it's a fiscal instrument. Another core to our forest policy framework is tenure, the way we allocate the rights to Crown Forest. And in exchange for allocating the rights to harvest timber, we expect obligations from licensees, among them a sustainable yield, protecting various environmental values. We don't provide for any carbon either obligations or incentives at the moment. And our tenures could be changed to authorize licensees to manage for carbon, and they could figure out what to do with those benefits they get out of doing so. That would be another big change. One way in which we have done that is in several areas in the province we have created organization-specific tenure arrangements called atmospheric benefit agreements, 3 of them with First Nations and then with a small community forest up near Whistler. The challenge is that thus far those only represent a very small fraction of the province, and we could choose to expand those dramatically. We could essentially create a relationship with every First Nation or every community forest or every licensee where you had this sort of mechanism for sharing carbon benefits between the Crown and whoever that non-Crown actor was. Another fundamental mechanism we have, and arguably the single most important way that we regulate for values in the forest, is the core statute of the Forest Range and Practices Act. It is designed to require licensees to protect for 11 different values in the forest, from recreation to watershed values, scenic values, et cetera. When it was written, carbon was not part of that construction of how we thought about forest values, and it was not included. But we could add it. We could add it through a simple legislative amendment, and it would be transformative in terms of the requirements on licensees to manage for carbon, and it would have a subsidiary effect where if you change the rules through FERPA, you would also be changing the way that we would be calculating the allowable annual cut to greater consider carbon mitigation values in the forest. Fire management, a huge issue. Obviously for the province, the Wildfire Act requires that we manage forest risks, and this leads to this common practice of slash burning. We could shift the way we do that management to encourage or require greater consideration of carbon in forest management, in fire management, sorry. It would be a very challenging thing to do so. In terms of the harvested wood products, we do have mechanisms designed to encourage wood use, but they're relatively soft and gentle. We have a Wood First Act, which gives a general soft invitation to people building buildings with government funds that they should consider wood first, as long as it's consistent with codes and other values. It has probably led to an increase in the use of wood products, but taking that next step of being a little bit more directive, for example, requiring through codes that all buildings be built with wood unless there's a really good reason not to, is not something that we have really stepped forward to think much about. But if you want to get serious about wood use in buildings, you could take a more directive approach. Bioenergy, another major issue, and that shows up as a huge thing in the mitigation scenarios. We currently have modest policies to encourage wood bioenergy use, including a couple of secondary tenures, but there is little direction provided in policy about the specific use of bioenergy, and we could, if we want to, provide for financial incentives or regulatory requirements for bioenergy use where it is a net contribution to greenhouse gas emission reductions. And finally, we could directly use funding from government to invest in the forest to have it mitigate more carbon. The Forest Carbon Initiative was announced as part of the Climate Leadership Plan back in the summer. More recently, the Premier announced $115 million to the Forest Enhancement Society in BC to help begin rehabilitating the forest in part for this purpose of greenhouse gas mitigation. But there's not currently an operational plan that's been made public or a funding plan that's been made public that actually shows a way that the province could use that sort of strategy to meet the 12 million ton objective that it set for that in the Climate Leadership Plan. So we could fill that gap by developing that operational and funding plan more rigorously. And just to conclude, really we are faced with a situation where our value shift towards greater concern to carbon has not yet been reflected in policies, so our climate policies have only modest coverage of forests, and our forest policies generally ignore carbon. We could change both of those things if we choose to move in that direction. For this part of the project, the next step is to gather more stakeholder input on what the options and issues are here, and then do a more elaborate policy analysis where we'll take a series of structured options and look at a set of criteria such as mitigation effectiveness, cost effectiveness, and administrative and political feasibility. Okay, so that's my contribution for now. I should hand it over to
All right. Hello, my name is Guillaume Peterson. So I'm working with George on Theme 3 of the PICS project, which looks at financing policy options. So I'm a UBC PhD candidate at the Institute for Resources, Environment, and Sustainability. What I'm going to talk about today is the PICS engagement project, which is part of all of this big project. So we decided that we had to talk with people around BC to see what they think of all of these different alternatives and also the policy gaps that we see. There's many policy gaps. So what can we do to go forward and really use all the opportunities that are in the forest? So the point of the PICS engagement process is really to see where carbon fits within the whole spectrum of values that we use to manage the forest in BC. So carbon is one of them, but there's many others. And so today we really looked at carbon and some socioeconomic, but there's many other values that we need to consider also when we look at these opportunities and alternatives. So the project, the engagement process is separated into 3 phases. So first phase, which we did last year, was the first series of workshops with stakeholders and First Nations around the province to define objectives for managing the forest. So what are important things to consider when we develop those mitigation alternatives? And I'll go more in details into them. Second phase was actually the developing of the alternatives, which we saw with all the presentations this morning. And then the phase 3, which is going on now, is a second series of workshops, and we also did a public survey to get a sense of what people think of these alternatives and how we can improve them. So the first phase, we went to 4 regions. We did 2 workshops here in Vancouver, one in Nanaimo, one in Kamloops, and one in Prince George. That was at the beginning of 2016. So we had a very, very diverse group of participants. So NGOs were very well represented, many environmental NGOs, development NGOs, also tourism. We had a lot of small-scale forestry representatives, so consultants, a lot of community forests also, and also big industry, some First Nations, some people from academia and carbon offset companies, and local regional government. We purposefully did not invite the federal or provincial government to keep the process really focused on stakeholders and First Nations. So what we did during that first phase is to identify objectives. So the definition of what we gave as an objective is really simple, is what really matters when we think about climate change mitigation in the forest sector. So we identified many objectives. So in the 5 workshops, we had over 30. The team got together and we looked at these objectives, tried to put them together. The things that were similar were bumped together. We have sub-objectives that define what is an objective. So I'll go over them quickly. So the first 4 are really the ecological or environmental focus. So the first one, which is not a surprise, is to maximize climate change mitigation by reducing emissions or increasing removals. The second one is climate change adaptation, which is also very important, especially now with the impact that we're seeing on our forests on climate change. And the 2 others, they're really ecosystem services that are co-benefits from also managing for carbon. Biodiversity was separated because many people thought it was important to have it separately, and especially for old-growth forests, and especially on the coast. And for ecosystem services, they put together all the other very important services that we get from the forest, so soil quality, air quality, and also recreational, spiritual opportunities. The next 6 strategies are really more social and economic oriented. The first 2 are associated with First Nations. So the first one is really a given, and it's to recognize First Nation rights and claims to their forest land, which everybody agreed that should be on that list. The second one was to increase, particularly for the First Nation, their economic opportunities and role in the forest and forest sector. And then increase provincial net economic benefit. So that's really industry competitiveness and value-added products. Increase socio-economic benefit, which is basically employment. And then the last 2 is resilience of local communities. So really focus on providing them with opportunities, and not only the big forest companies, and also minimize the negative impacts on local food security, which is a bit surprising and comes mostly from Prince George, where there's a lot of afforestation projects which they take agricultural land and transfer them into forests. So that was an issue there. And the last two are more on the process side, so ensure evidence-based decision-making, both the science but also traditional knowledge, and the social license and political feasibility of these alternatives. So we also asked the respondents after the workshops to rank these alternatives. And so this is the ranking from 1 to 9. This was ranked by approximately 70% of all the participants of these workshops. So the most important, which is not necessarily surprising, is the environmental benefits. So ecosystem services came first, then the climate change mitigation, biodiversity came very up the list. And the lower one are the economic incentives and benefits. So now phase 2. So you saw the 5 strategies. We're going into the, so we had development and modeling. I won't go into details into these strategies because we already talked about this morning. We added a 6th strategy, which is rehabilitation. The reason we did that is that it's going to play, and it was identified as a very important role in the climate action, climate leadership plan. And so we added it to have an idea of what stakeholders think of this strategy. And we're working now on modeling the impacts of this strategy. So also the output of the modeling, so we went over this. So there's biophysical, economic, and socio-economic outputs. So now what we're doing now, and we actually had a workshop yesterday in Nanaimo, so we're going to the same communities again, and this time we're going to ask participants to evaluate the 6 strategies based on the objectives that were identified during the phase 1. So yesterday was very productive. We had good discussions, a lot of agreements, which is very nice and surprising. So there's a document that we created for this consultation process. There's some copies outside, I think. So it really goes over all of the strategies, all of the process from phase 1 to phase 3, and what's in the next phase, and what's the goal of this process. And they also define the 12 objectives that were identified. So another part of this project was a public survey that was sent out in January to the general public, so 1,500 people. And we asked them to identify the support for these 6 strategies. We had a lot of questions. I won't go in detail in the results, and they're going to be published soon. But so we have the 6 strategies, and the 2 in red are 2 that we added. So increased growth rate, which is using fertilizers or increased seeds or other ways to make trees have better growth rate, and also increased harvest. So it's to actually increase the area we harvest per year. And we asked the public to indicate their level of either support or of opposition to these strategies. And there's a broad level of support for most of these strategies. In the average, all of the strategies were supported, although increased harvest was really on the limit of not being supported, which is not necessarily surprising. The strategies that were the most supported is rehabilitation, which is all over the place. People saw the impact of the mountain pine beetle, and they want to take actions towards that. And also old growth conservation is really on the top of the list of what people want to see. And all of the other strategies that are enhanced forest management are also very supported. And people realize that these strategies are not necessarily an intensive forest management, but it's really to improve our management. So we also looked at the survey at other results. So what affects these level of supports? What are the characteristics of why people would support or not? But I won't go into details on this. So just as a conclusion, so there's an overall agreement on a set of objectives. People were agreed on it. They did not necessarily agree on what's more important, but we know that what we should look at when we develop management strategies. The most important are environmental ones, ecosystem services particularly. So the incoming workshops, and anybody that wants to participate, you're welcome to. In Vancouver, it's going to be in June 8th, so just contact me. So we're going to evaluate those strategies. And for the survey, in general, there's a high level of support and a broad level of support for any of the mitigation strategies we asked about. And there's multiple variables, as I said, that can predict public support. Environmental values, which is not very surprising. Perceptions towards climate change. So if someone perceives risk, they're going to be more supportive of mitigation strategies. Trust in decision makers was really a big factor. Prioritized objectives. If you support conservation, there's some strategies you're going to prefer over others. And then socio-demographic, political view in particular. So this is all about it, so thank you very much. And
thank you, Guillaume, and all the other speakers we had in the last session, So what we want to do is go to part 2 of this. Perfect. Okay, so the last presentation before we have a second round of questions is a quick outlook of what lies ahead. And before I do that, I should also say that as part of today's event, we have put a series of infographics about the project on the PICS website, and you saw them as printed copies on the display stands in the break outside. You can look at them after the meeting as well. We also have a small series of blogs that relate to these topics, the primer that Guillaume was talking about. So all of that material is available on the PICS website, and as will be a recording of this session today as soon as that production process is completed. And there's other information, background information on the project, as well as links to the scientific papers, many of which are open access, so you can just click on it. You don't have to be a subscriber to the journal. I'm not 100% sure that that's true for all of them. If it is not, just email one of us and we'll be able to email you that paper. So next steps. This is a 5-year project. We're in the 4th of the 5 years. We have committed funding to March 2019. And what I want to do is just give you some examples of the ongoing activities that the team is in the process of doing. The first and most important, I think, is the ongoing refinement of analyses. As Carolyn explained to you, we are seeking feedback. We will be doing more analyses, more model scenario runs to manage expectations. These are time-consuming and demanding tasks, so it may not be possible to do each and every one that is proposed, but what we're in the process of doing is looking at what assumptions, what input data, what assumptions are questionable or people would like to revisit or refine, and then we will do as much as possible additional analyses with the overall goal to help improve our understanding of the mitigation options and the scenarios that are available to us. There are a few things where the data are simply weak at the moment, and it would take years. It may in some cases not even be possible to really materially reduce the uncertainty of parameters, and so what the scientific community does is we have forms of sensitivity analyses that then allow us to evaluate the impact of these uncertainties on our estimates. And this is particularly important when in situations where an uncertainty in parameter may change the ranking. An uncertainty in the absolute value is perhaps less of a concern than a situation where an uncertainty may lead to choosing one mitigation option over another. That's something that we need to be aware of. Another task that we're working on for multiple reasons, Robbie already mentioned the need to go spatially explicit because of the important influences of microclimate, site, topography, elevation aspect, and various other things. But it's also important to be spatially explicit because it will allow us to better estimate things like transportation costs. Does the wood residue or the wood move on paved roads or on unpaved roads or on self-loading barges? So there are various issues that we want to better address by moving towards a spatially explicit modeling environment. This is, again, computationally very expensive and work that is ongoing and in progress, and it's done also in conjunction with other work that our team at CFS is doing with other players across the country and internationally. We also continue our interaction with other PICS projects, as you heard from Sybil. The built environment also deals with the question of the use of wood products and what that means for carbon stored in buildings, but also for energy efficiencies, et cetera. The Energy Futures project is also looking at the contribution of biomass and bioenergy, and that's also true for the transportation project, where one of the things that Sybil said is that about 23% of emissions in British Columbia come from the transportation sector, where it is possible to use residues or wood waste. to create liquid biofuels that could be used in long-range transportation. That could be a huge contribution to British Columbia's greenhouse gas emission reduction targets, because at the moment we can't electrify semis and trucks that travel long distances as necessary to move goods and services across British Columbia. Robbie spoke about the climate change impacts. This is going to be ongoing, a huge effort. We do need to further improve our ability to predict the climate impacts on growth and mortality rates. And as you saw from many of the maps that Robbie showed, there are huge differences across British Columbia. We cannot assume that there will be uniformly positive or negative impacts. It varies by species, it varies by regions, and it will likely also vary over time. So what we need to do is get a better understanding of where in the province we will likely see areas that may require responses, such as salvage logging and planting of trees that are more suitably adapted to the new environment, drier, warmer, etc. Or other areas where, through enhancement of forest growth of existing species, we have opportunities to take advantage of things like CO2 fertilization effects and other environmental changes that may lead to greater carbon sinks. The other thing we need to do is understand the interactions between what we do with proposed climate change mitigation actions and climate change, and so that in the end we can design regionally differentiated mitigation strategies that support both mitigation and adaptation goals. George spoke about the policy analyses and stakeholder engagement processes. As said by Guillaume, there's an ongoing consultation process. George and his team will be conducting analyses of some of the policy options to help us better understand what some of the opportunities and constraints are. And ultimately, this overall effort is designed to develop policy recommendations that are based on the results of modeling, so science-based evidence, and policy analyses and stakeholder feedback. Then lastly, synthesis and integration. This is a multi-year big project involving many different people. So one of the things that we will be doing towards the end of the project is developing and preparing science policy notes, ways in which scientific information can be communicated to a larger audience, scientific, technically, or lay people. And we need to find ways to do that. We are considering maybe a small symposium or an event like this to share the end of project information as well. We heard one comment from the audience about how things could be done fundamentally different. And I think we all need to realize that when people speak about a goal of reducing 80% of greenhouse gas emissions by 2050, we really need to rethink many aspects of how we conduct our activities in our societies, in our Western societies and elsewhere. In British Columbia, we are in a truly unique situation. We have one of the highest per capita forest areas in the world. And not only that, the forest area is predominantly owned by the public, the Crown. We have about 12 hectares per person, and statistically speaking. And of course, because the lands are owned by the Crown, that means they're owned by the public, and we can have a say in how these forests are managed. We have another advantage in British Columbia, and that is we have a lot of know-how. We have a well-developed forest sector. There's a lot of innovation going on, not only in the way we manage forests, but also in the way in which we produce wood products. There are a number of companies that develop really innovative products, wooden spans over hundreds of feet, and various other products like mass timber buildings. What we're trying to do with this project is explore a future vision of how BC's forest sector can contribute towards emission reductions and meet, at the same time, other objectives of society. So I think this vision, if we get to that point, is also a way of communicating it with the public and helping people understand what some of the choices are and the alternatives that can be made in order to meet not only carbon management objectives, but also aspects of how we would like the desired future conditions of our forests to unfold. So in closing, we've sort of been developing a little clickbait, I guess is what they call it, sort of a list of 10 steps towards forest sector mitigation. I'm just going to go over these and just give you an idea of some of the elements that can contribute towards this vision that we're trying to develop. We all understand that growing more trees and growing them faster are ways to increase carbon stocks. We clearly, even though this is not a big issue in British Columbia or Canada, land use change, conversion of forests to non-forest land uses, whether that's a parking lot or a settlement, human infrastructure or anything else, avoiding land use change, like we expect our colleagues in tropical and subtropical countries to do, is an area in which we can make a small contribution in British Columbia. It has not been getting a lot of attention because we're not talking about huge areas, but it is something that nonetheless can be done. And of course, the inverse is also true, afforestation or reforestation, to bring land that was in non-forest land uses back into forestry uses where that's appropriate, and being aware, of course, of the food security issues that were raised in the north. Using harvested trees first for long-lived products. I think when we take a piece of wood out of the forest, we should ask ourselves, what can we do to maximize carbon retention in harvested wood products, because that keeps the carbon out of the atmosphere. But we could also ask ourselves, how can we reduce wood waste at every stage? If we look at construction sites, sometimes there are enormous amounts of wood waste from cuttings, from whatever. If you walked around the construction site at Brock's Commons, there was no waste at all because everything was manufactured off-site to very high accuracy standards. And like a big Lego kit, once they brought it to the site, they just had to assemble it. And the wood waste, where it did occur, was in a centralized facility and was then being able to be used for other purposes. When we do use wood, we want to maximize avoided emissions. So where we can use structural lumber in place of concrete, it releases 1 ton of cement to produce, 1 ton of CO2 to produce 1 ton of cement. So avoiding concrete where we can and using wood instead in these mass timber buildings that are being designed now, we do have opportunities to avoid emissions through wood use. We still have practices. We used to have, for those of you who are older in the province, we used to have beehive burners. The most efficient way to get rid of wood waste was to just burn it. It was already in a central location, and it was just burned. As far as I know, there's not a single beehive burner operating in this province anymore. And so we certainly don't want to burn residues or waste unless we can capture the energy. And of course, where there are residues and waste, the first question we need to ask ourselves is there something else we can do with it other than burning to retain carbon longer and use it for products that have greater substitution benefits. Conservation of forests does play a role. I think, as Carolyn said, we need to be aware of the risk of reversal. It may not make sense to conserve a forest that is at high risk of a beetle attack or fires. But as people in the audience, Jens and others have mentioned, we have high carbon stock forests with very low risk of natural disturbance, and that also contribute many other societal values, from recreation to spiritual to wildlife habitat. And we need to ask ourselves whether, from a carbon management perspective, and for other reasons, of course, because forests are not managed for carbon alone, whether conservation of these areas makes sense, in particular where we have second growth forests that could be used instead. We need to anticipate the impacts of climate change, and we need to align our mitigation and adaptation objectives accordingly. We cannot simply go out and develop a mitigation strategy and apply it one size fits all to the whole province. We need to be mindful of the fact that there are different processes occurring at different rates, some positive, some negative for forest growth, and we need to align our mitigation strategies accordingly. As we are going forward to invest into climate change mitigation actions, we need to monitor the consequence of these mitigation actions. And the reason is that some will require investment of public dollars, and we need to be able to document and demonstrate to ourselves and to the people of British Columbia and Canada who pay the taxes to make some of these things possible, that the consequences of our activities did indeed contribute to the outcomes that we sought, both with regard to greenhouse gas emission reductions, but also with regard to other benefits, whether that is employment, community employment, or co-benefits of these activities. Failing to do so will not allow us to sustain the public support to use the forest sector and climate change mitigation strategies. I think having lived in this province for over 30 years now and having seen many of the often very acrimonious debates about forest management in this province, I think it is important that for this new chapter that George was referring to as public values are shifting, we remain disciplined. We take a dialogue-based approach that makes decisions based on scientific evidence wherever possible, to not only seek the public support for forest sector climate change mitigation strategies, but to also sustain it and demonstrate to the public that what is being done is indeed aligned with their values and their interests. So finally, in conclusion, I hope we were able to demonstrate to you today that the forest sector in British Columbia can make indeed a significant contribution to mitigating climate change and how this could be achieved. And also that if we if we start these mitigation actions soon and sustain them into the future, these mitigation benefits will increase. You saw the slide from Zach that showed that by 2020, there's very little we can do with forests, but by 2030 or 2050, there's a lot that we can do, and if we go further into the future, the opportunities increase further. Implementation of mitigation actions in British Columbia requires investment into BC's publicly owned forests. That's why it's so important that we have the public support for this, but also that we monitor and report the outcomes and the achieved emission reductions. By being able to report, we can document the contributions to mitigation that we achieve, but it also increases the transparency and accountability of forest management, which ultimately, I believe, will lead to sustained public support. The PICS research project will continue to identify how the forest sector can support BC's transition to a lower carbon economy. I thank you very much for participating in the process. There are more questions that we will turn to in a moment. It's your feedback that in the past and in the future has made this a better project because it allows us to look at different angles on the questions that we are pursuing. So in closing, I want to thank all of you for participating. As I said, we will open up for questions in a second, but I want to thank everybody also from PICS, SFU, and elsewhere who helped make this morning a success. So thanks to everybody who participated, and with that, I'll open it up for questions. Thank you very much. And George, Robbie, and Guillaume, why don't you come up since that was your section? And we've been asked to sit down here so we can use these microphones, and maybe we can just move that over to this side without dropping it. That looks safe. Just sit down. Questions, please. And can you also let us know if there are questions from afar? Yeah, go ahead. Actually, we need the microphone for him. Who's got the mic? This one.
So good morning. Great presentations, everyone. I'm curious. My interest is in biofuels, and so in BC we use about 8 billion liters of gasoline and diesel a year. And we have policies and regulations like the carbon tax and renewable fuel standards for gasoline and diesel, as well as the low carbon fuel standard, to incentivize use of biofuels, but we have very little production in BC. The province has an intention to see production in BC to lower the carbon intensity of fuels used here. I'm curious how much your analysis is targeting biofuels, and if I can encourage further targeting.
Yeah, so that's a good question. We have not yet paid a lot of attention to it. We have mostly focused on other bioenergy sources, so electricity and heat. But I would say over the last 12 months, the awareness of the need for biofuels on a deep decarbonization pathway for British Columbia has become increasingly clear. There's a lot of really exciting work going on at the University of British Columbia. And actually just last week I was in Quebec. I spoke to representatives from companies that have a lot of experience back east in building biofuel facilities. And they are very interested in moving west with some of that technology. The interesting and sad situation there is that all the biofuels that are produced are being shipped to the United States because of the renewable fuel standards there. And that, of course, is one of those unfortunate outcomes, because any use of a wood product that leads to an emission abroad is considered carbon neutral in the foreign country, but shows up as an emission on our greenhouse gas inventories. So if we ship fuels or pellets to Europe, that adds to the greenhouse gas emissions of British Columbia, because under the international reporting and accounting rules, we're responsible for the emissions from wood products that were harvested in British Columbia, Canada. And so what that means is that as part of this discussion that we have within the PICS community and the universities, is how can we design a future pathway to bioeconomies in British Columbia, or low carbon economies, where the fuel is not only produced here but also used here, so that it helps offset our emissions, our own emissions. And in fact, we have, and he is not here because he just finished his PhD comprehensive exams and took off to his homeland. We have a PhD student who is working on this project, who's looking at some of these very questions about how do you design a low-carbon economy that is either outward or inward focused with regard to exports of long-lived products or biofuels. So certainly a discussion that I'd like to continue in the future. Other questions, please? Can you pass the microphone to Jens?
Thanks again for all the information. It's really great to see so much work underway to raise awareness about forest emissions and what we can do to reduce them. I have one big picture comment and question related to it. So one fear I have is that we could see our government continuing to de-emphasize fossil fuel emissions and getting very excited about emphasizing the opportunities to reduce emissions from forests. And I think we have work to do to be really clear with our governments that we expect them to be very serious about reducing emissions from fossil fuels and in addition from forests, because if we would see a strategy emphasizing forests and continuing to neglect fossil fuel emissions, allowing new fossil fuel projects to get built, that would directly undermine not only our future but also all our efforts to reduce emissions from forests, because there would be so much more damage in our forests. And my question related to this is, in the past years, forest emissions were not counted as official emissions, and they would not contribute to our overall progress or lack of progress reducing emissions. So in the future, how is there a change? Will there be a change that would allow technically our government to say we can achieve 35% of our 2080 commitment looking at our forests? And if this would be possible, how can this work if we all almost have certainty already that there will be more catastrophic years? Some years, fires and insects will be so bad in the coming decades that even if there would be ongoing efforts to reduce emissions from fossil fuels and doing all these things in the forest that are positive, they could be totally overwhelmed by these climate impacts. So how could this be done technically? So it's a two-part question. Will there be a change in how we report our emissions, and how can we actually distinguish our positive work from the negative climate impacts?
Yeah, thank you, Jens. And this is a very informed question. It also, to do it justice, would require a very lengthy answer. I'll try to keep it very short. The fundamental issue is that historically the Intergovernmental Panel on Climate Change in the United Nations Framework Convention on Climate Change, under which greenhouse gas reporting occurs, have recognized the difficulty of separating the influences in the land sector of human activities and of indirect human influences or natural drivers. And so wildfires in Canada are predominantly from ignition, from lightning sources. The vast majority of the area burned is not caused by humans. What the Intergovernmental Panel on Climate Change has done is they introduced what is called the managed land proxy. And so what they have done is said that lands that are deemed managed, all the emissions on these lands are deemed to be anthropogenic, of anthropogenic human-caused origin. And in a large country like Russia, Australia, or Canada with low population density but vast areas, that has created the problem that it confounds the emission from human activities with the emissions from natural disturbances. And as you said, we can have bad fire years in Canada where the emissions are completely overwhelmed by that single fire year. And so what Canada has done in accordance with the internationally negotiated agreements is in this National Greenhouse Gas Inventory report that was released April 15th to the United Nations Framework Convention. For the first time, we've taken an approach where we focus the reporting of emissions and removals in the forest sector on areas that were affected by forest management, and we temporarily remove from the reporting lands that were affected by these natural disturbances. But we not only remove them for the duration of the emission from the fire, but also for a period at the moment of 60 years following the fire to allow regrowth to occur, and that carbon removal from the atmosphere is also not reported. So you basically take the land that was affected by a fire, you don't account for the emission, but you also don't account for the regrowth that occurs. And so the consequence of that is that we don't report for 230 million hectares of land in Canada, but about 190. So there's 40 million hectares that are sort of rotating in and out of this naturally disturbed area. And what it does is now we have an emissions profile from 1990 to 2015, the last reporting year, that much more accurately reflects the impacts of human activities. So when before you saw a zigzag line of impacts from fires in some bad years, now you see a line that has a trend. It shows a decreasing sink as forests have been affected by increasing harvest rates between 1990 and 2005. You then see an increase in the sink as harvest rates reduced as a consequence of the economic downturn in around 2008 and the global economic recession. And then thereafter you see a bit of an uptick again, a reduction in the sink as a consequence of increased harvest rates. And so now you have a much more direct reflection between human activities and the reported values. And it is also basically a precursor to allow us to now implement forest sector mitigation activities and see these reflected in the actual national greenhouse gas inventories. Now, how individual provinces will take that federal leadership and implement it in their greenhouse gas inventories is ongoing discussion and is something that individual provinces will need to decide. But at least we now scientifically have the ability to more clearly document how changes in human behavior are reflected in the greenhouse gas inventory of the land sector. And so you will much more effectively see these changes in human behavior. Now, the downside of this is, like before, there's now an area that contributes to the greenhouse gas balance of the Earth that is not captured in these reports to the United Nations, which are designed to influence or to share the impact of human activities. So even before, we had unmanaged forests in the north or Arctic lands that are not considered managed lands, but that interact with climate change and will provide feedback to future climate. Those are not part, never have been, of the United Nations reporting. So independent of what is reported to the United Nations, there is a need for scientific activities to help better understand how these unmanaged ecosystems or ecosystems that are subject to natural disturbances will respond and what kind of feedback they will provide to climate change in the future. Failing to do this could create a situation where we achieve great outcomes with mitigation on the managed land, but at the same time, say, permafrost melting in the north and burning of peatlands in the north creates emissions that are as large or larger than the gains we make through the managed systems. And so that is a scientific challenge, and it needs to be done. It needs to be communicated to the policymaking community that while we are maybe achieving good outcomes on the managed land, and that's a good thing, we still have to deal with the effects of climate change. But those things will be much, much harder to deal with in the future, and that's why the Paris Agreement really is trying to keep temperature increases below 2 degrees, because then we have hope of these other systems' responses to climate change not providing the runaway feedback that is conceivable under an 8 or 10 or 12 degree warming of the world. There's more carbon in circumpolar boreal peat and permafrost systems. There's twice as much carbon in those systems than in the atmosphere. So if even a small fraction of that carbon were released as a consequence of climate change, the mitigation efforts in all other sectors will be severely undermined. So it's...
Managed emissions will be counted officially.
They are certain...
About British Columbia.
I do not know what British... And that's why I said, you know, what the federal government has now done in the NIR 2017, the National Greenhouse Gas Inventory Report, is laid the scientific foundation for a methodological approach that is still under review and that may be refined. We may not continue to use the 60 years across the country. We may use regionally differentiated values, et cetera. But in principle, we've laid out a scientific approach now that can be developed. And so now, by doing it this way, it reduces the risks for the individual provinces. One of the reasons why many provinces were reluctant to directly report this in their greenhouse gas inventories is because the fires, for example, of the beetles in British Columbia, can completely overwhelm the impacts of anything we do in other sectors. And so the intent of the greenhouse gas inventories is to report the consequences of human actions. And if you do that, but then you have this wild card in there, you know, you try to bring your greenhouse gas emissions down to a certain level, but then you throw in a bad fire year, and all of a sudden, you know, your legislated target is here, and you add this huge flux from something you can't control, then you're defeating all the purposes. And that's why this reluctance. Can we pass a microphone over, please?
I guess this is a little bit more in the looking forward to the positive opportunities with regards to the new political situation in British Columbia for regulation and policy shifting. Maybe George and others could feed input into the gaps that might be have opportunity for us, and maybe some ideas in terms of how we can and whether PICS and this whole process is going to have impact and how we can strengthen that impact in terms of furthering positive policy shifts provincially. My second question, I follow 2030, the organization based in the States that does a lot in terms of architect, design, building kind of dynamics in terms of shifting. And I'm just also wondering about opportunities in terms of our building code, what kinds of things are possible for bringing this long-lived wood product dynamic into greater options here in BC and Canada.
So I'll leave the second question to others. On the first question, I think it's important to recognize how deeply uncertain the political situation is right now. The two most likely scenarios are that there will be a Liberal minority government supported by the Greens. And if that's the case, you'd look most at what the Liberals have done in the past, which is they have been talking for quite a long time about the importance of carbon in the forests, but have been quite slow to change policies to address that. If you add in the Green component on that, if you read the Green Party platform, they're actually extremely enthusiastic about finding ways to use the forest to better manage climate change, and they're also more willing to invest public money in doing so. So I would think that even with a Liberal minority government, there would be some greater push to move in that direction. The second most likely scenario, and I'm not saying one's more likely than the other, I'm just saying the second likely scenario is that there's an NDP minority government supported by the Liberals, or a Liberal NDP coalition. And in that case, you'd see a much more profound structural change in policies across many policy areas in British Columbia, including forest policy. The NDP has been historically greener than the BC Liberals by far, and it's definitely been more willing to use public money and public
direction to help shape forest and forest policy. So it's possible that we could be in for a significant amount of change. We are very much hoping that our policy analysis and process will be directly engaged with the government of British Columbia, but that's completely up to them to figure out how they want to bring us in and involve us in that process.
I'm also interested in just how do you have any ideas how we can strengthen that E&GO industry stakeholder opportunities in terms of defining and pressuring for some of those policy shifts? Public inquiry, looking at previous, forest policy analysis.
So I think especially as this project unfolds, we have a great deal of information useful for the development of new policy. The challenge has always been to get the political will to change things. And so it certainly helps to have external stakeholders pressuring government to do that. But as is frequently the case, governments get pressured in different directions on these things. And what I've been noticing going through this process is even though carbon is the new value we're arguing more about, the differences between British Columbians and those who emphasize the productive economic values from the forest versus those that emphasize the environmental values of the forest are still quite profound. And any government, Liberal Green or NDP Green, is going to have to finesse that challenge.
So on the other question about enhancement of wood use in long-lived products, as I indicated earlier, there's certainly opportunities through building code changes and other regulations. In British Columbia, the vast majority of single and multifamily, well, single-family homes are built from wood already. So the opportunities lie in multi-family residences, small apartment buildings, condominiums, but also in non-residential buildings, whether that's schools or sports arenas and the like, as well as industrial facilities, shopping malls, etc. So opportunities exist. I think we're always seduced by the 18-story buildings. In the car community, I'd call those the Ferraris or the Teslas or whatever. But what moves the masses are the Hondas and the Toyotas and the Volkswagens. And so what we need to do really is understand that finding ways to get into the mass market for having climate change mitigation benefits is probably more important. That the 18-story buildings demonstrate to us what is possible and what will be possible in the future, and that will make it easier to convince the public to live in an 8 or 10-story building. The other thing that we need to recognize is that this is a global problem. There are hundreds of millions of housing units that need to be built in coming years as the developing world continues the process of urbanization. And so our export markets like China or Korea or others, if we can work with those communities to use our products in long-lived products instead of using them for casing, for concrete forms, etc., which tend to be very short-lived, again, if we can work with those markets, we will have opportunities to contribute to climate change mitigation using the products that can be sustainably derived from BC forests. We have a couple of questions online.
Yes, yeah, we have one from Northern Local Government, and it's addressed to George. How is promoting wood use progressive unless there is also protection against logging for natural old-growth forests, which are excellent at storing carbon and whose logging releases large amount of carbon? This includes interior old-growth forests.
Is that a question for me, Werner, or a question for you?
I think it was clearly for you.
Everything else being equal, the promotion of wood use in buildings is definitely pro-mitigation. The challenges are producing the wood in a way that's sustainable given the variety of values we have in the forest, including carbon. And that's what our scenarios that have been developed in the modeling are designed to kind of tease out the different ways in which there are sources and sinks in these different processes to best to optimize mitigation in that sector. And it's a combination of these forest set-aside strategies, higher utilization, and significantly increased wood use in buildings.
I'll add something to that, and that is, it's not only how much wood we harvest, but what we do with the wood that we have harvested. In 2016, British Columbia exported 6.3 million cubic meters of unprocessed logs. In the context of another meeting recently, I did a back of the envelope calculation. If we took that wood and converted it into cross-laminated timber, which is the thick walls that are used in these mass timber constructions, we could build 1,000 Brock's Commons buildings. That's that 18-story building that is built at UBC. We could build 1,000 of those every year, and not only that, we would have about 4 million cubic meters of residues left that we could turn into about 300 million liters of diesel, and that's about 8% of what's used in British Columbia right now. And not only that, we still would have some energy left to produce electricity and ethanol. And so, in other words, just the amount of wood that we're exporting as unprocessed logs right now, if there were incentives and economic reasoning behind using that domestically, there's a huge mitigation potential that is available just through that amount of wood, and that would not require 1 extra cubic meter being harvested. It's just taking the wood that is already being harvested and using it in a different way.
Yeah, and the other question is just would like you to expand in the point number 1 of the 10 steps towards forest sector mitigation.
Okay, so one of the things that we know from comparing the carbon efficiency of forest management, say in Canada, with similar systems, boreal systems and temperate systems in Europe and elsewhere, is that carbon management, forest management in British Columbia has historically been very extensive. The argument that we were taught in economics in universities and that has been applied historically to management in British Columbia is that if you invest money today and harvest the wood 30, 40, or 50 years in the future, any reasonable discount rate applied to the future revenue will give you a negative net present value to date. And so what that means is that we have historically been discouraged to invest public money into forests because it does not give a return on the investment that is justifiable. Having said that, the situation is now changing, because if we get payment for ecosystem services, in particular carbon sequestration, we could do things in the forest today, more enhanced forest management, a series of silvicultural activities that we know can be applied that will enhance carbon storage in forests and growth rates. And if that incremental carbon that we accumulate in the forest as a result of more intensive management is assigned a value, which in society we apparently pay $30 a ton of CO2, so that's a cubic meter of wood equivalent. If you go to a forester and say, what could you do with 10, 20, 30 or more dollars per cubic meter of wood in terms of enhanced silviculture, tree planting, in-planting in areas that have big holes due to natural disturbances, or whatever, there's a long list of things that are available, from forest fertilization to planting to enhanced silvicultural management. The point is, these are all things that create more values in the forest, that create employment, that create carbon benefits, that we cannot do right now because economically it's not justifiable if we get a return on the investment 30 or 40 years from now. If we can use carbon values to provide an economic return to those who make these investments, then all of a sudden the economics change completely and we can have a different discussion in this province about whether or not it makes sense to invest. And then finally, of course, governments can choose to invest simply because it may be the right thing to do. And certainly, some of the things that could be done in the non-timber harvest land base of British Columbia, which is about 60% of our forests, in which we historically don't harvest for a variety of reasons, governments can simply make the choice to invest into that land base. They don't expect future harvest, but they achieve a carbon benefit from that, and that can be justified on the basis of these carbon costs and carbon benefits. Jens, go ahead. And
very quick.
Sure.
I think it's okay.
No, you have to because of the recording.
So I think I missed hearing about allowing trees to grow older. So for example,
yes.
Longer rotation,
yep.
Was that part of one of the scenarios? Like 120 instead of 60 years rotation on the coast or something like that?
It was not on the list, but it's certainly part of enhanced forest management. So there are certainly opportunities, and we have done such analyses in work that we've done in the United States. Just recently in Wisconsin, we looked at one of the scenarios where we simply increased rotation age by 10 years. So that with everything else being equal, that results in a reduction in harvest levels because you can harvest less as a consequence in that particular landscape. And then we looked at the benefits in terms of increased carbon storage, but you also then have to account for or take into consideration the reduced harvested wood products that are available as a consequence and the consequence for displacement factors. So it's this trade-off among the three pillars that we're looking at. I think this is certainly something that we will look at here. I mean, the restrict harvest, the reduction in the harvest level, is in effect an extension of the rotation length as well. Although in many areas of British Columbia, we harvest well below the AAC already, so that the theoretically available harvest level is not actually harvested in many areas of BC. There are some exceptions, particularly where the mountain pine beetle had big impacts. Okay. Go ahead, Robin. But please use the microphone, which is behind you. And then I would say maybe one or two more questions after that, and then we'll shut it down. And we can have informal dialogue afterwards.
This is probably very quick answers to these questions. It's probably obvious to most people in the room, but I was just wondering, this may be more related to Caroline's presentation, but creating bioenergy from waste wood, obviously a huge benefit for mitigation. I was just wondering what the effect is of nutrient levels on forests when you take out the waste wood, because I think traditionally the idea might have been it was good for the ground, but some sort of clarification around on that would be interesting. And also with George, you mentioned atmospheric benefit agreements, and I was just wondering if you could expand a little bit more about them, how they work and how effective they are, because they sound intriguing, but I'm not really sure how practical they are for expansion and that sort of thing.
Yes, thank you for the question on nutrient levels for capture of residues for bioenergy. So the issue is the nutrient levels decrease, and so the productivity of the subsequent regrowth would be reduced. And so that is an issue. We tend to not take the nutrient-rich portions of the residues, like the foliage that's left behind. And we also don't take we don't take all of the residues. We only take a portion of them. So when we did the analysis for BC, only 40% of the residues were captured, and the rest was left behind. So it certainly can be an issue, but we think we are at residue capture rates that are low enough that we don't affect the future regrowth.
And just to strengthen that, the majority of the nutrients are in foliage and in twigs and in the very fine material. And so when you take out the residues, the wood has a relatively low nutrient content. And so as long as we, as Carolyn said, leave the rest behind, the long-term impacts on the nutrient balance of the site is relatively low. And there have been studies done since the 70s that looked at this, because this is not a new question. And so as long as we don't start practices where we remove twigs and fine branches and foliage from the site, leave that material that's very nutrient-rich behind, then the impact on the nutrient balance in the long term is minimized.
And I'll answer the question on the atmospheric benefit sharing agreement, or atmospheric benefit agreement. So they were called atmospheric benefit sharing agreement before. So they were first out to allow First Nations to do the projects on their land and be own part or all of the carbon credits. So when you do an offset project. So this is what it was thought at the beginning. And now it was transformed to atmospheric benefit agreement, because you could own all of the credits and not only a sharing, and also it included other forestry, community forests, for example, PICSClimateInsights forest projects. So there's only 4 atmospheric benefit sharing agreement at the moment. And so it allows any manager of the land basically to do a project on public land and own some of the credits. So it can be an offset project, it could be conservation, it could be reduced harvest, it could be enhanced forest management. So the PICSClimateInsights is enhanced forest management, the Haida Gwaii and all the Great Bear Rainforest, they have ABAs, and it's more conservation and also improved forest management. Yes, in some cases, yes, and in some cases there's some discussions. But in general, if the accounting is well done, yes, they are effective projects. And then you have to account for all the issues with offsets, including leakage, which is a big issue.
Okay, well, thank you, everybody. It's 10 after 12. We're a little bit over time. We started late. We split the difference. We have no more questions online either, so thanks, everybody. We'll be here for a few more minutes, and appreciate everybody coming and contributing to a very constructive discussion. Thank you very much.